I'd like for us to consider this reaction. We have the reaction that takes place between magnesium and hydrochloric acid. And based on this molecular equation, I'd like for us to construct the net ionic equation. So looking at this molecular equation, the first thing we have to do is we have to ensure that our equation is balanced. If we look, we see that we have one magnesium on the left, one magnesium on the right. We have two hydrogens on the right, but only one hydrogen on the left. And we have two chlorines on the right, but only one chlorine on the left. So we're going to need to multiply by 2, multiply our HCl by 2 in order to balance our equation. So now our equation is balanced. We need to go ahead and assign our state symbols. Magnesium is a metal, okay, and with the exception of mercury, all metals are assigned the state symbol solid. Okay, so magnesium gets the state symbol S. Hydrochloric acid is aqueous. All acids are aqueous. Magnesium chloride, we need to check the solubility for chlorides. All chlorides are soluble except for silver, lead. So our magnesium chloride is going to be aqueous, and hydrogen is a gas. And you would have a list of some of the more common gases, so you can refer to those. Okay, so now we have our balanced molecular equation. We have our state symbols assigned. So now we need to go ahead and identify the compounds that are aqueous and split those compounds up into their respective ions. Now, magnesium is a solid, so we're not going to trouble it. We're just going to write it back. Okay? Now our hydrochloric acid, or HCl, there is a 2 in front of the HCl, and that 2 there is to ensure that the equation is balanced. So what it means is that we have 2 H plus ions. We have to ensure we put back the 2. This 2 here was balancing the molecular equation, which means it is also going to balance our ionic equation. So we have 2 H plus ions. Those were in aqueous solution, and the 2 also multiplied by the Cl, so it means that we have 2 Cl minus ions, and those ions were also in aqueous solution. Those reacted to form magnesium chloride. Now magnesium forms an Mg2 plus ion, which is in aqueous solution, and we have Cl minus ions. How many Cl minus ions do we have? We have 2 of them. So because we have 2 of them, I know that the temptation is to do this, but that is not correct. The way you're going to show that you have 2 Cl minus ions is by placing the 2 in front of the ion, and those 2 Cl minus ions are in aqueous solution, plus our hydrogen. Hydrogen is a gas, so it is going to remain unchanged. We're not going to do anything to the hydrogen. So please, nobody let me see you writing this. This is nonsense. Hydrogen is a gas, so it should not carry any charge. Likewise, the magnesium should not have any charge when it is in its solid state. So we're not doing anything to the H2 gas. We're not doing anything to the Mg solid. Now we have our total ionic equation. What we're going to do is we're going to go through and look for the spectator ions. We're going to look for our spectator ions. We're going to cancel them. We're going to get rid of them. So the only spectator ions we're seeing are our Cl minus ions. Cl minus ions are the same on both sides. So we're going to cancel them out. 2 Cl minus aqueous on the left, 2 Cl minus aqueous on the right. After that, we're going to write back all the species, all the substances that we have left. So we have our solid magnesium plus 2H plus ions, giving us Mg2 plus ions in the aqueous state, plus H2 gas. So this is our net ionic equation, all right, based on the molecular equation that we were provided with.